Alright, today we're going to be multiplying polynomials, or monomials. In this case, the first few cases we're just multiplying two monomials together. I know they're monomials because they don't have any addition or subtraction signs in them. And so I'm just going to multiply 5 times 4, which is 20. And then we've also learned that we add our exponents together, because this really says x times x, and this says x times x times x. So you can see that really we have 5 x's being multiplied together. So a reminder on that rule is that we add our exponents together. That's different than we're adding. Let me go ahead and show you. If this was being added together, this would be the simplified answer. So if I was adding, I could not add these together. This would be the answer. Adding requires like terms. On the next problem, we are multiplying again, so I'm going to multiply 1/3 times 12. 1/3 times 12 happens to be cross reduce. You get 4. So I have 4, and then I have x squared times x cubed. There isn't any x's over here, so I have x. Keep my base, add my exponents. Then I have y to the first times y to the fourth. So 1 plus 4 is 5. And then z, I've got z to the second times z to the fifth. 2 plus 5 is 7. My answer is 4x to the fifth, y to the seventh. With some more examples here, now we're going to take a monomial and distribute it through the polynomial. So what I have is I have 4 times 5, which is 20. B times b to the second, this is b to the first. So I'm adding 1 plus 2, which would be b to the third. Bring down your plus sign. 4 times 1 is 4. B to the first times b to the first is b to the second, because you're adding 1 plus 1. Plus 4 times 6 is 24. And I carry my b through. There's nothing that can be added together. None of those are like terms, so that is my answer. On the next problem, I'm going to go ahead and change my signs to plus the opposite before I begin. And then I will be distributing this to each of the terms. Negative 7 times 3 is negative 21. This is h to the first, so I have h to the first times h to the second. So I end up with h to the third. Plus negative 7 times negative 8 is positive 56. H to the first times h to the first is h to the second. That's 1 plus 1. Plus negative 7 times negative 1 is positive 7. Carry my h through. My next problem, I'm going to change my signs to plus the opposite. Distribute. So I've got 2 x to the first times x to the second is x to the third. Plus 2 times negative 6 is negative 12. X to the first times x to the first is x to the second. And then 2 times 5 is 10. Carry my x through. Number 6. Distribute again. So I have negative 2 times 3, which is negative 6. G to the third times g to the third is g to the sixth, because that's 3 plus 3. Plus negative 2 times 6 is negative 12. G to the third times g to the first is g to the fourth. And then negative 2 times negative 5 is positive 10. Carry my g to the third through. We've got 2 more like this, and then we'll be starting another bit of a topic. So I'm going to distribute again. So I've got 6 times 2, which is 12. X to the first times x to the first is x to the second. Minus, or you can change it to plus the opposite, negative 18. Carry my x through. Down here I've got 5 times 2, which is 10. X to the first times x to the first is x to the second. And then 5x times 1 is just 5x. Again, none of these were being able to be added together because you do not have like terms when finishing multiplying those problems together. Alright, the next type of problem we're going to do is with a binomial times a binomial, and we're going to use this an acronym called FOIL. And so what we're going to be doing is multiplying the first terms, then the outer terms, then the inside terms, and the last terms. So let me go ahead and show you what that means. I don't think it's a big deal to really say FOIL or not use FOIL, but a lot of people talk about foiling, so I will mention it. The first terms are considered to be the first terms of your binomial, so the x times the x. So that would be your first terms, the f. The outer terms are considered to be the outermost of the parentheses, so that's your O. But really what you're doing, and the logic behind this, is you're really distributing this x to both of the terms, the second set of parentheses. Then what you're doing is you're taking the second term, which happens to be a -1, and you're distributing it to both sets of the parentheses. These are your inside terms. And finally, you take your -1 times the 9, which would be your last terms. So there's the first, outer, inner, last. Now let's go ahead and multiply those together. Blue, so x times x would be x squared. My outer terms were done in red, so x times 9 is 9x. My inner terms are -1x, and then my last terms is -1 times 9, which is -9. Really, again, all we're doing is we're taking this first term and distributing it to the second set of parentheses. Then we're taking the second term and distributing it to the second set of parentheses. So we're doing two sets of distribution. The last thing we can do on these problems is we do end up with like terms. So my final answer is going to be x squared plus 8x plus -9. On the next example, I'll go ahead and use the colors again. Here's my first terms. First times first is x squared. My outer terms, x times -10 is -10x. Inner terms, 3 times x is 3x. And then my last terms, 3 times -10 is -30. Combine my like terms together, I end up getting x squared, -10 and +3 is -7x, and then plus -30. My last example, a lot of people want to just distribute this through, but that's not legal. What this really says is I have m minus 3 times m minus 3. So what that means is I really am going to be foiling again. I'm going to take my first times my first, which gives me m squared. I'm going to take my outer terms and multiply them together, which gives me m times -3, which is -3m. And then I'm going to take my inside term, -3 times m, which is -3m. Then I'm going to take my last term, multiply them together. -3 times -3 is a +9. So I've got m squared, -3 and -3 is -6m, and then plus 9.